Hello, my dear friends. Welcome back, all of you, after such a long time, isn't it? We're all busy with the result declaration. So many things were happening in and around us. So, yes, yeah, back to business again. Yeah, back to business. Let's resume with our classes. This is already the month of August. So, we have about only 5 months left now, to be precise, 5 to 6 months left before your turn comes to write on the exams. All of us celebrated during these results. All of us are happy for the success of our friends, our seniors. Your turn comes now, next. So I hope you are mentally preparing for that. And as I was telling you, this is already the month of August. I am sure that you must have realized that. Start counting your number of days. Please start studying properly. Okay, please start focusing on your studies. If you were still lost, sorry, I was not able to be with you for, I guess, maybe 3 to 4 weeks. So yeah, I was caught up in so many things. So because of that, that's why I couldn't, get in touch with all of you. But yes, as I say, we are back now, back with our business. Time to move on with our syllabus. So, but before we begin today, I would just like to, take this small special moment just to, just once again, just to thank each and every one of you for your continuous support, because it is because of your continuous support only that, as I always say, we get the motivation to do what we love doing, that is, reaching out to you and teaching you of what little knowledge that we have. So yes, once again, a big thank you to each and every one of you for your continuous support. Actually, I was kind of uh, I had what do we call it, like I was kind of thinking like, okay, after such a long time I'm going to be conducting live classes. I wonder how many students would turn up, but looking at the number of students that are turning up, there's nothing new. You have always been good. You continue to remain the same. So my blessings are with you. So all right then. So without wasting much time, hopefully, I hope that we will be meeting very soon. Let's hope for the best. Situations, I believe, are getting slightly better. So let's hope for the best. But till then, let's continue. So I hope you have gone through the videos of the logarithmic, of the videos on logarithms, and also the first one or two problems which I had solved for you. So I believe that you've gone through that. So we will just continue from where we stopped. So I think up to question number 1, 2, and 3 I have solved it for you. So let's begin with question number 4. And yes, of course, a very good evening to each and every one of you, all of you. Thank you so much for joining. That's why, as I was telling you, I was kind of a little bit, doubtful, because after so many days we are going live again. So I was wondering, I do not know how many students would really be joining, but it's so nice to see all those regular students joining in. So that's really motivating for me. All right then, let's continue. Okay, now question number 4. I left this particular question. I solved up to question number 3 only. So I left this particular question because this is a very different question again. This question number 4. If you remember, I hope you have your notes with you, all those notes that I had given to you previously. I hope you have all those notes with you. So if you remember, if you can just turn out, turn on those pages where you have written down the notes. There, I have given you the logarithmic, the product rule, the quotient rule, the quotient rule. But I'm very sure, and in that particular video, I mean, in the last video only, or that particular video, I have also mentioned specially that, yeah, good evening all of you, that this is not possible. Because logarithm, as I have expressed that, I'll not repeat that again, expressed that in that particular video. This is also, log is also a separate function. So I told you that this also has its own laws. So there I mentioned that this is also not a product. So if you have gone through those videos, this is not possible. This is not multiplication, no, log of n into log n. No, this is not possible, because only product rule we have, where if you have into m into n, then fine, then no problem. So what I'm trying to tell you here is, many students actually, what happens is they have this problem, okay, especially with this kind of question. What they will do is they will directly apply log. So don't write, okay. I'll be showing you what many do, which is wrong. What they do is, most of them, they will just apply log. They will just apply this log. And next step, what they will do is this. Very simple, so simple. Aram se. Wow. Just now only I told you that log m plus n or m minus n, this is not a product that we will just multiply distributive law and then log m plus log n or log m minus log n. That's not possible. Because we do not have any laws for m plus n until unless somebody has discovered it recently. So far we don't have. So in that case, how are we going to solve this problem? Just be careful there. Alright, definitely I'm going to show you how we solve this particular problem, but just be careful when you get this kind of questions. All of a sudden, sometimes when having some easy questions, you just come across, this can be just solved easily. No, please, don't do any stupid mistakes. I don't want you to be losing any marks. What we will do now here is, alright, let's name this as equation 1. You can do it in different steps. Steps to, as I say, that depends on the person. I'll be naming, since I see two different functions here, I'll be naming the functions separately. That is like u equal to, this first function, and v equal to the second one. Okay? So in that case, what happens is, y becomes u minus v. I guess no doubt with that, then y becomes u minus v. So differentiating both sides, then it would imply differentiating both sides, I'll have with respect to x. I'll not write on that. That differentiating both sides with respect to x, and also differentiating both sides with respect to x, I have this function. I have this equation. I'll just name that as equation 2. So here what you'll have to do is you'll have to solve this separately. Find out u with respect to x. It's easy, okay? It's not difficult at all. You just have to do it separately, that's all. You will also have to differentiate this separately. Find dv with respect to x, uv, or you can name any other letters also, any other functions also, and differentiate and find dv with respect to x and substitute in equation 2. Then you will have dy with respect to x. This kind of functions when we have to differentiate with respect to x. Is that clear? So now, since this is done, what we will do is, I'll go back. Now, u equal to x power x. So here, I don't want to be writing, but okay, just for this, let's say, taking logarithm, L-O-G-A-R-I, taking logarithm on both sides. Taking logarithm on both sides. So now what am I trying to do? I'm trying to find out du with respect to x. So taking logarithm on both sides, I'll have log of u equal to log of x with respect to x. So just one more step again. Log of u equal to x into log of x, the exponential form. So now I'll differentiate with respect to x. So in that case, it will be 1 by u du with respect to x, chain rule, implicit functions also, is equal to, now this one product rule, again differentiation of product function, again don't forget the basics again. So that's x into, chalo, this one let me just write, differentiation of log x plus log x into, see this kind of, from here actually from this exercise what will happen is problems are going to get actually bigger, okay. So we will have to actually skip the simple steps. For this step, of course, I'm writing, but afterwards we'll have to just do some of the integrations just mentally, okay? So x we cancel. So then ultimately what do we have here is du with respect to x becomes u, what was the value? X power x, if I'm not mistaken. Yeah, into this is 1 plus log x. Let's name this as 3 just to be systematic. But so u with respect to x is already done. And what was the other function? V 2 power log x, was it? 2 power sine x, sorry, 2 power sine x. 2 power sine x. So as I had already told you, it's not that every time you have to take logarithm. It's not compulsory that you really have to take, logarithm. What did I say in that previous video? Those who have watched the previous video, I told that this is just a tool that is given to you to help you easily differentiate some certain special functions. But if you can differentiate without the help of logarithm also, no problem with that. No problem with that. By that what I mean is here I'm not going to be using logarithm. I'll just use the concept of chain rule, because a very rare formula that we use in differentiation. You remember this? A power x into log a. I guess you remember this. So that's what I'm going to be applying here. So this one directly differentiating. So that's a power x is a power x 2 power sine x log a. But of course it is not x, so we will not forget the chain function. The chain rule. Oh yeah. Done, no? This one? Alright, so this will be equation 1, 2, 3, 4. But so now u with respect to x also, v with respect to x also done. So what shall I write? Okay, it's up to you, using 3 and equation 4 in, I think, equation 2. So that was y with respect to x is equal to u with respect to x minus v with respect to x. I think that is all fine there. So the time to substitute. Okay, now this one finished. Chalo. So chalo substitute karo. I'm not rubbing this because I need this. Maybe I can just do like this. So u is this one minus v with respect to x. What was it? This one. 2 power sine x log 2 cos x bus. So that's why here problems actually get very big. Okay, so that's why we just cannot afford to do all the steps again and again and again. So we have to skip at least some of the steps. Okay. Done? If you're done, we can move on to the next question. Alright, next question, of course, that's quite simple. Number 5. Always name the function as I had told you earlier. Please follow the videos systematically, okay? And don't jump from one video to another video, because everything is given but in the textbook in a very systematic order, and which is not, I'm trying to give it to you in a very systematic order. So do not, skip the videos. So chalo, here too it's all product only, so we can just use log. So now I'm not going to write down taking log on both sides. Okay, let's reduce some steps so that we can save some time. Not today, especially in the exams. Our purpose is to save time. I hope you have gone through the interviews of those students. So time management is very important. So if you manage your time properly, then definitely it depends on you, how to manage your time. For some, 3 hours is not enough, but for some, as you must have gone through the interview, even 2 hours is enough. So that depends, it's a lot of difference in the perspective. These things are all not new. To bring on the other side exponent, the power 4. Now this is already done. Chalo, let's differentiate then, shall we? So I'll just write implies. So differentiating both sides with respect to x, implies 1 by y dy upon dx is equal to 2. Log of x is 1 by x. And in the last video I have told you that if you want to proceed with chain rule, you can proceed, but why waste time when you can mentally do these simple questions? So when you go for differentiation, especially the last video, I had shown you exactly how it is done. So please go through that video. I'll provide you the link below if you feel lazy to just check all the playlists and all. But this one also I've clearly told you, when you go for the chain rule, differentiation of x, okay, just one. Don't try, but I'm just going to show you. So I'll have to proceed like this. Now, so in that case, differentiation of x is how much? 1. Differentiation of 3 is 0. So no remainder term comes here. So that's like, it's not that we are not applying chain rule. We are applying chain rule, but nothing new comes out. So that's why, okay. And this one also 3, 1 by x plus 4. This one 4 into 1 by x plus 5. So further simplifying, dy by dx is equal to y 2 by x plus 3, 3 by x plus 4, 4 by x plus 5. Then substituting the value of y. What was the value of y? X plus 3 whole square, x plus 4 whole cube, x plus 5 whole power 4 into, if you want a textbook answer, you can take the LCM. That is x plus 3, x plus 4, x plus 5. So that's going to be 2 into x plus 4, x plus 5 plus 3 into x plus 3, x plus 5. I'm just going to write up here. I think that's fine. Plus 4 into x plus 3, x plus 4. I think that's all right. So 1x cubed 1 1. So this one cancels, this 2, this 3. So you almost have your textbook answer: x plus 3, x plus 4 whole square, x plus 5 whole cube. And this one I'll leave it to you. 2 into x plus 4 into x plus 5, 3 into x plus 3 into x plus 5, plus 4 into x plus 3 into x plus 4. That one you kindly, just simplify, and I am sure that the answer will be something like 9 as per the textbook. If you don't get the solution, you can let me know in the comment section below later on. And that's where I'm not getting the solution, so maybe I'll just solve it, but I'm sure you will get. This is just simplification only, so you'll end up getting something like this after simplifying. 9x squared plus 70x plus 133. So let's just save some time of that multiplication and addition and simplification part. All right. So you can just leave some space. You can try that afterwards later on. Okay. Done. Chalo. That would be, next question would be number 6. Always write the function, okay? Let y equal to x plus 1 by x whole power x plus x power 1 by x. So I guess you remember what I told you in the beginning of the class, first class, a function, addition of two functions, plus. So what do we do here? In this case, plus or minus, we cannot take logarithm directly, isn't it? We can't do that, right? So what do? We have to solve it separately. So by separating the functions. Let this be equation 1, that's the question. We have an addition, subtraction. Remember, only product and that quotient comes for log. So be careful with that, okay? Okay. All right, then let's start differentiating both the functions separately. Let's go to the first one, u. Done, huh? So now u equal to x plus 1 by x whole power x. So maybe this time I'll just try to do it like this. So taking log on both sides. That's it. We've already taken log on both sides. All right. So let's differentiate. So differentiating both sides, we have 1 by u with respect to what? The x product. This function, two functions. So x into, shall we do it directly? Let's save some steps, okay? Let's do it directly now. So this into differentiation of log x. So that would be 1 by x. What is x here? Following the concept of chain rule, this. So we will have to differentiate. Okay, for the chain rule, let's write down that step so that we will not be confused. I'm just continuing here. Plus log of x plus 1 by x into derivative of x. Product rule. Okay, time to solve, simplify this. So that's x. This one, if you just take the LCM, I'll just do it here, LCM. So that's x squared plus 1 by x. That's fine. This one, differentiation of x is 1. Differentiation of 1 by x. Differentiation of 1 by x, what was it? If you remember, minus of 1 by x squared. Plus log of x plus 1 by x. I guess you can see now up to here. Differentiation of x with respect to x, okay, that's 1. Okay, what was u? This one. Okay, let me just save some space. X goes up, that becomes x squared plus 1 into, if you take the LCM here, x squared minus 1. Okay. Plus, of course, this function remains unchanged. So, हो गया? So x square गायब. I rubbed anyway, चले. So du with respect to x is, what was the value of u in that function? X plus 1 by x whole power x into this value becomes x squared minus 1 by x squared plus 1. I'll wrap that part. Plus log of x plus 1 by x. So this would be, I think, equation number 3. Huh? That's the first part. And okay, what was our function v? Second, x power 1 plus 1 by x. Oh yeah, that is one. So here also we'll have to take log because it's variable power variable. I'll just write here, okay? Okay. Oh yeah, log simplified. Shall we differentiate then now? So differentiating both sides, we'll have 1 by v dv with respect to x is equal to, product again, 1, 2. So I'll start with 1, 2. So 1 plus 1 by x. What is differentiation of log x? 1 by x plus log x. Differentiation of 1 to 0. Differentiation of 1 by x. Okay, 0 minus 1 by x squared. So I'll just move up here. So dv with respect to x is equal to v अच्छा इसका क्या करेगा? I'll just take the LCM. I mean this one x plus 1. Chalo. X plus 1 by x upon 1 by x. I mean into. And this one minus 1 by x square log x. So I'll just write here. Maybe if you cannot see, just 1 by x square log x. So v value is x power 1 plus 1 by x. Common LCM x square x into x is x square, no? So I'll have x plus 1 here minus, this is also common, log x. I guess that's fine. X plus 1 minus log x upon log x square. So that would be dv upon x. I believe this should be question number 4. It is not difficult, my dear children. Yes, it just takes, some patience. You have to be very orderly. You have to do it very steadily, very steadily. So now both the functions are all ready, just to combine omega. So, chalo, I'll write using 3 and 4 in 2. So dy by x is equal to this, x plus 1 by x whole power x, x square minus 1, x square plus 1. Plus log of x plus 1 by x. What was it? dv u by x plus, I think v by x plus, isn't it? Yes. Plus. Shall I just continue here? I'm quite lazy, so plus this value. This guy is for us, so we have to write, but he to writing shortcut. Upay nahi sometimes. Alright, so today also you see we have already reached the half-hour mark. So what to do, my dear children, when we reach the half-hour mark? Yeah, take a small break, drink a glass of water, get refreshed, and come back again and continue, na? So those who have not finished, you can note it down. Those who have finished, you can get ready with the next question. Don't worry, I'm not going to be taking for the whole night tonight. After a long time, we're coming for online live classes, so definitely yes. We are going to solve not all the problems, some problems. Okay, by the way, I just wanted to get an opinion. Do you prefer the live classes more, or you prefer that new way of recording classes where I just write for you, solve? Of course, both are good, but I just want to know, like, Of course, I'll be doing both, but I just want to know your preference also. Like, which one actually do you prefer? This, you prefer these live classes more, or you prefer, that new way of uh, giving you videos? Which one do you prefer? Log x power x plus x log x. Okay. Hmm. Alright, so it seems like many of you prefer live classes. Okay, I'll keep that in mind. But the recorded classes which I provide, please do watch those videos also. Okay. And yes, try not to skip the ads. That's the only way you can support me. So I request, if you get time, try not to skip the ads. That will really help me a lot. I should not have. Anyway, a request. That's the only way you can actually support me also. So I'll be very happy if you don't skip the ads, especially when you have time. Actually, not when you're hurrying up and all that time. Don't. That time you just skip it. So okay. But when you have time and then when you're watching that time, chalo, do me one favor. You're already doing me a lot of favors. So chalo. Yeah, you better watch. Maybe the next class test, I'll be putting MCQ questions on what advertisements did you watch. I did not say that. Forget it. Chalo, let's continue. So it's almost the same again. So now alright, so that's done. Log simplified. Time to differentiate now, shall we? So differentiating both sides, 1 by u du upon dx. So we have two functions. This is one and this one. So let's start the product rule. X into, okay, differentiation of, look here, listen carefully, my dear students. Hello, hi, look here. Chalo. This into differentiation of log x. What is differentiation of log x? 1 by x. 1 by, what is x here? Log x. So yes, chain rule shall follow again. This one, no? Log x. x plus log x into differentiation of x with respect to x. Do we really have to write that? I think that's enough. No more of writing. So okay, I'll just write one. Just wrote it. Chalo, can. So u with respect to x is equal to u into x by log x. Differentiation of log x is 1 by x plus log of log x. So x cancels. And what was u? U was log x power x. Log x power x 1 by log x plus log of log x. I think we can leave it here. Okay, we'll just follow as per the textbook. So what they do again is they will begin taking the LCM. Log x power x. I guess you can see up to there, no problem. So I'll be taking the LCM here. So LCM will be log x. So here 1 plus log x into log of log x. So let's skip this part. So that would be u with respect to x equal to, so log x, another log x here. So as we all know, x power n divided by x is nothing but x power n minus 1, isn't it? If I just take it up there. So that's all the same. Nah? Log x, same function. So that I can write it as log x whole power x ak 1. Nah? So minus 1 into this one. 1 plus log x into log x. Okay, let this be the third equation, number 3. Yeah, so we are about to hit the half century today also, 49. So who's going to be that 50 wala likes? About to hit that half century mark, what? Reduce only, 48. It was 49, somebody just reduced it. Okay, we have hit that half century mark. Chalo, wow, everybody. Congratulations. Who hit that? 51? I mean, just to say thank you. Who hit that half century? 50, wala, especially that 50. Don't worry, I'm not going to be giving you extra marks for that. No. Chalo, here also we'll have to take log be equal to log x log x. So that would be log v log x log x. That will be again log x log x log x log x. So that if you wish, you can write it as log x whole square. There are many ways to do this, no? Isn't it log x, so that's like log x whole square. Let's try it. So that can be again written as log v twice of log x. Let's just try this. I haven't tried this. Let's just try this. So now differentiating both sides. 1 by v upon x twice of differentiation of log x is just 1 by x. So v upon x is v 2 by x. So the value of v x log x 2 upon x. So 2 I'll just bring forward, and x, so this is x power 1, this is log x, so that's log x, just to write it something like this, log x minus 1, power, okay, exponent, dv upon dx. Is that fine? 2 by x, the value of v is x power log x, so x power log x. So x power log x power 1. So law of indices, so 1 I'm bringing up, so x power log x minus 1. 2 I'm just bringing it forward, 2. That's done. So that's it. Now just have to combine. Okay, let's write down this as now what? Equation 4. Yeah, equation number 4. So as usual, please write down using equation 3 and 4 in equation 2. Using equation 3 and 4 in equation 2. Good evening, Himanshu. You seem to be very early for the class anyway. So using equation 3 and 4 in equation 2. I'm not going to write on that, so you just write on that. So again, as usual, I'll be just trying to save some energy. So that would be dy upon dx is equal to this. And what was it? Plus or minus that value? Plus, no? Number 7, isn't it? Yeah. Plus, okay. Plus twice of x log x minus 1. Just hold on. I think we missed out something somewhere. This one is alright, this is no problem. This one, the second one, log x, I think we missed out somewhere. That's what I doubt. Okay, let me just do that quickly. V equal to, what was it? Anyway, sorry for that. X log x still. X power log x. So log v equal to log x log x. So log v equal to log x log x. So log of v equal to, if I just do it separately, just check once. I think we missed something somewhere. Can you check, because I think log x is somewhat missing from somewhere. I don't know from where. Anyway, just try this, log x whole square. So after this we just differentiate. After this, if we just differentiate, I think we missed something somewhere, but anyway, let's forget that. I'll just continue. Just keep this. I'll just try this once. I think we missed out somewhere. Sometimes it happens, no? So 1 by v dv upon dx is equal to, differentiation of this would be 2 times of log x, 2 minus 1, chain rule, derivative of log x. So that would be v upon x, v twice of log x, derivative of log x is 1 by x. See, that's what I meant. So the value of v was x of log x twice of log x by x. This is what we missed. Up to here it's fine. After that I think oh, so sorry, I got that, so sorry. I'm so sorry for that. I beg your pardon, I'm so sorry for that. Actually what happened, what mistake we did so sorry for that, okay. Actually what happened is, I'm so sorry. Actually, see, this is fine. Up to this it was fine, okay? Up to this it was fine. But after that we made some mistake. I made a mistake, not you, sorry. I made a mistake because we have the theorem for log of x power n. X power n as, see, it happens even with us also sometimes with teachers, no? N power log x, but we don't have for whole power n. We don't have that. It's a good thing that we came across this particular problem so that in the future you will also be careful about that. Just trying to make an excuse, but no, seriously, it's a good thing that we came across this particular problem so that maybe you will also not make that mistake again. So I'm so sorry for that. It happened unknowingly. That's why it happens with us teachers also. So I'm so sorry for that particular mistake. So this is from where we made, I made that mistake. This step. So you got my point, no? Because after this, next step what I wrote was, if I remember, it was log v. I wrote 2 log x. Now that was not possible. That is not possible because, as I was telling you, we have formula for theorem for log x power n. That is n into log x. But we don't have for whole power n. No, we don't have that. That we cannot write it as n power log x. All right. So it's a good thing that we came across this problem, so I'm so sorry, okay? Alright, so I guess that's clear now, okay? So I beg your pardon, please. हो जाता है ना कभी-कभी sometimes, so but it's a good thing that otherwise maybe in the future if we had not come across this, maybe you might have made mistakes. So it's a good thing that we came across this so that we could learn from the error. Always take life positively. That's what I always used to say, right? So always try to find a good thing in anything that happens. Bad, good, whatever happens. So that's something positive that I'll take from that mistake that I've made. I hope you got the point. I think that's clear. All right. So that is where I actually overstepped. So that should not happen. Please don't do that in the exams also. So whenever you come across that particular problem, please do remember me. Okay, that idiot made that mistake. So let me not follow that idiot. Let me follow this one. All right. Okay. Done. So yeah, that's all. So after that you can combine. So that will be plus at the end, 2x log x minus 1 log x. That's fine now. Okay? Okay? I think that's all clear, all fine. Alright, shall we do one last problem? It's already been almost 1 hour, so let's try one more problem. Last problem for today. Y equal to, you see, these problems actually take a long time to solve, okay? That's why you can see, here this kind of problems log x power n. So that too we can take x. But earlier, that last problem we had whole power n. That's why that was the problem. No? Alright, x into again product rule, x log of sine x. So log of x is 1 by x. And differentiation of sine x is cos x plus log of sine x, differentiation of x is 1. Cos x by sin x, cot x. So let me just write down that here. The value of u sin x power x. X cot x plus log sin x. I think you can see that, no? So this would be question 1, 2, 3. I hope you can see that part, no? And v was sine inverse root over of x. So here I'm not going to be taking log. I'll just differentiate using chain rule. That is dv upon dx would be differentiation of sine inverse x was 1 by root over of 1 minus x squared. But what is the value of x here? Root over of x. So we have to follow up with chain rule. So here I'm not taking log because I can easily differentiate. So that's why I'm not taking log here. So 1 by root over of 1 minus x. Differentiation of root x, what do we have? 1 by 2 root x. 1 by 2 root x. So just to simplify, 1 by 2 root x root over of 1 minus x. So dv upon x would be 1 by 2. So root under 1 root. X into 1x, x minus x, x squared. So that would be equation 1, 2, 3, 4. See that first function, this one you cannot do without taking log. This one you have to do with taking log only, because as I say, we don't have any formula for x power x, variable power variable. So the first function without log you cannot differentiate. Second one, since it just follows some basic, requires the knowledge of basic chain rule only, we could do without log. First one you can't do that. I think last class also I told, we have the formula for x power n. We have the formula for a power x, but we don't have any derivative formula where we have x power x, variable power variable. This question was this one, sine x power x, so it's function power function. We don't have any formula for that. So the first one you can't do without taking log. Okay, so the first one you have to take log. Second one we could easily do without taking log. That's why I just easily did that. Alright, so log, you can just make some corrections there. Okay. Alright, so that's it. So finally you can just conclude using equation 3 and 4 in equation 2. Using equation 3 and 4 in equation 2. Using equation 3 and 4 in equation 2. So that would be okay. I'll just write this one since this is the last one. Let me just write it properly. That is sine x power x, x cot x. Sometimes it gets confusing, I can understand, but as I say, mathematics, it is all about practice only. So take your time, spend time with mathematics. I'm sure next year one of you definitely will do us proud. Not one of you, many of you. I'm sure on that. I'm counting on that. I'm really proud of many of you here. Okay, again, huh? So I think that's it for today. We'll just wind up here for today. I'm again sorry for that previous mistake. Okay, unknowingly, it just happens. But good thing is that because of that we learned a mistake which could have happened in the future. So please, yes, as I say, don't do that. Okay, if you come across that, please do remember me. Remember that idiot who was making that mistake. Okay, so don't do that mistake. It's a good thing. That's a positive thing that we came across today from my mistake. Okay, so I'll see you in the next class. We'll try to, I don't know whether we'll be able to finish or not, because this problem, just one problem also, it takes such a long time. So we'll try to solve it. We'll try to finish it. I'll see you very soon in the next video. So till then, please do watch all the videos. If you have skipped any videos, please do watch all the videos. And take care, stay safe, and I'll see you very soon again. Okay, so bye bye and good night.